Hello friends, Mr. Burrell here. In this particular lesson, we're talking about creating equations from word problems. And as we are in Math 3, this is going to be a good segue into preparing for the ACT. The ACT loves word problems or story problems or wordy problems. So hopefully this lesson kind of helps us be familiar and comfortable or more comfortable than we have been maybe in the past with dealing with story problems, writing equations, and using that knowledge to solve problems, okay? So hopefully by the end of this lesson, you can write equations, inequalities based on story problems, and then use those equations to solve, to find an answer, okay? So first of all, let's just review some basic terminology. These are, again, things that you should already know. But there are terms that are going to pop up on occasion when dealing with a math problem, when it's in a story problem format using words. So remember that sum, when I see the word sum, that's talking about the solution to an addition problem. So the sum of two numbers is the result of adding them together. Difference is talking about the solution to a subtraction problem. So if I say the difference between these two numbers, it's talking about subtracting them. Product is the word that I use to denote the solution to a multiplication problem. The product of two numbers is what I get by multiplying them together. And the quotient of two numbers is what I get when I divide those two numbers. So those are some general terms that we'll see often enough in story problems that might help us with some of these types of problems. Okay? So don't be afraid of these story problems. Don't be afraid of words in a math context, right? This is going to be, if we can get comfortable with dealing with these types of problems, we're going to be all the more prepared when we take the ACT or other exams, okay? So we'll start with some relatively simple ones. Okay, a car salesman earns $30,000 salary plus a commission of $600 for every car he sells. He wants to earn $80,000. How many cars does he need to sell? So we could potentially solve this problem without writing an equation, but for practice, let's write a mathematical equation that's going to model this situation. So a car salesman earns $30,000 right off the bat. That's his salary, okay? He also earns a commission of $600 for every car he sells. That means every car he sells, he makes an additional $600 on top of his salary. So I'm going to go ahead and write a plus 600, but I'm not just going to write plus 600 because I get $600 for every car I sell, okay? I don't know how many cars this car salesman is going to sell, so I'm going to denote the number of cars he sells with a variable, with x. So 30,000 plus 600x, that needs to equal the total amount of money he wants to earn, which is 80,000. Okay, there's our equation set up based on this problem. 30,000 plus 600x equals 80,000. So now let's go ahead and solve this equation. I'm going to go ahead and subtract 30,000 on both sides to get rid of 30,000 here. That's going to give me 600x equals 50,000. Okay. I'm going to divide by 600 on both sides. Okay, that's going to give me x equals 50,000 divided by 600 is going to give me a little over 83, like 83.33 cars. So if he wants to make $80,000, he's going to need to sell 84 cars, you can imagine, because if he sells just 83 cars, he's going to be a little bit short, and you can't sell 1/3 of a car. So he's going to have to sell 84 cars in order to make that much money. Okay? Let's look at another example. A school football game charges $5 for students and $8 for adults. The football team really wants new uniforms that are going to cost $1,200. If 50 adults come, how many children need to be with them in order to meet this cost? Okay, so let's talk about this. So I'm going to charge $5 for students. Okay, so I'm going to write $5. I don't know how many students need to come yet, so I'm going to times that by, say, x. X is going to represent how many students need to come to this football game. Okay. I'm going to add that on to the number of adults. Okay, so I charge $8 for adults. I do know how many adults are coming. There's 50 adults coming, so I'm going to go ahead and multiply 8 by 50. Okay, and I need that to total to $1,200 because that's how much these uniforms are going to cost. Okay? So let me simplify this a little bit. This is going to be 5x plus 8 times 50 is 400 equals 1,200. Okay, then this becomes an equation that is hopefully relatively easy for you to solve. I'm going to subtract 400 on both sides. It's going to give me 5x equals 800. Then when I divide by 5 on both sides, 800 divided by 5, let's double check that here, is going to be 100 and 60. So 160 children, students need to come to the game with these 50 adults in order to make $1,200 that are needed to buy the new uniforms. Okay, so 160 students or kids or however you want to say that. Okay, so there's example number 2. Example number 3, the difference. Okay, so now we're going to get into some of this terminology that we talked about at the beginning. The difference of a number n and 6 is greater than the product of 4 and that same number n. And I'm asked to solve this inequality. So first of all, I'm going to have to write an equality. Let me start writing stuff. The difference. Difference means subtraction. So the difference of a number n and 6. That's what the difference of a number n and 6 is n minus 6. That's going to be greater than the product of 4 and the number n. Product is talking about multiplication. So the product of 4 and that number n. Okay? So really, I have n minus 6 is greater than 4n, and I need to solve the inequality. Okay? Well, we've done this before. I'm going to go ahead and subtract this one n to this side, and that's going to give me negative 6 is greater than 3n. I'm going to divide by 3 on both sides, and I'm going to get n is less than negative 2. Or let me go ahead and write it this way. N is less than negative 2. Both of these are saying the same thing. Sometimes we like to read it this way with the variable on the left. But there you go. I had to use my knowledge of this terminology, difference, product, to write an inequality and then solve it. Okay, that's example number 3. Example number 4, another similar one. The sum of the product of a number n squared and 6 and 3 is 57. Find the number. Okay, so sum. I'm going to write a plus sign here. The sum of, so let's figure out what I'm adding together. So the sum of the product of a number n squared and 6. Those are the two things I'm adding together. 6 and the product of a number n squared. So the product of a number n squared and 6, oh, sorry. I'm summing this and this. So this whole part of the sentence here is describing this first part that I'm adding. And then 3 is the second part I'm adding. And then this is, that usually denotes an equals. That's equal to 57. So let's write out what the product of a number n squared and 6 is. Product, that's talking about multiplication, of a number n squared. Well, here's my number n. Let's square it. The product of that and 6. I'm going to go ahead and rewrite that as 6n squared. So the sum, at addition, of the product of a number n squared and 6, there's the product of a number n squared and 6, and 3 is 57. Okay? Now let's solve this. I'm going to go ahead and subtract 3 on both sides, giving me 6n squared equals 54. I'm going to divide by 6 on both sides. It's going to give me n squared equals 9. And how do I undo squaring something? I square root. So the square root of 9 is 3. Okay, the square root of 9 is 3. And technically you could probably write negative 3 here too, because negative 3 squared would also give me a positive 9. Okay? So there you go, example number 4. Example number 5. Bobby is having a growth spurt. He is currently 34 inches tall. Let's write that down, 34 inches tall. And if he grows 2 inches a month, this is quite the growth spurt. If he grows 2 inches a month, how many months will it take for him to reach 4 feet tall? So let me write something that is going to be a mistake. I'm going to go ahead and write 34 plus, I want to grow 2 inches every month. Okay? I don't know how many months I'm going to need to grow for, so I'm going to use X to denote however many months it's going to take. Equals, and I'm going to put a 4 here. This is incorrect. The way this problem is written, we might be tempted to put a 4 here, but note that I started with Bobby being 34 inches tall, and I want to be 4 feet. Well, those are 2 different measurement units. So I'm going to go ahead and convert this 4 feet into inches. To convert feet into inches, I'm going to have to multiply by 12, because there are 12 inches in a foot, which is 48. So I really have 34 plus 2x equals 48. Okay? Let me hurry and solve this. I'm going to subtract 34 on both sides, which gives me 2x equals 14. If I divide by 2 on both sides, I'm going to get x equals 7. So Bobby's going to have to go for 7 months in order to get to be 4 feet tall. Okay, example number 6. This one's a little bit sneaky. This is almost straight out of a practice ACT problem. This is likely a problem that you might see on the ACT. So this says the sum of 3 consecutive odd integers is 189. What is the middle integer? This looks kind of exciting. So first of all, sum. Sum means addition. I'm adding 3 different things together. So I'm going to go ahead and write 2 different addition signs. I'm adding 3 different things together, and the answer is 189. Okay? It says I'm adding 3 consecutive odd integers. Okay? Note that an integer is just a number that I count like on my fingers with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in this case, since we're talking about adding up to 189, those are going to be positive integers. So I'm not dealing with negative numbers. So consecutive means next to each other. So consecutive odd integers would be like 1, 3, and 5, or 11, 13, and 15, etc., etc. Okay. So I need to find 3 consecutive odd integers that add up to 189. Well, let's say I denote the first odd integer as x, okay? Well, how would I denote the second odd integer? Well, to get from one odd number to another odd number, how much do I have to add by? Well, I have to add 2. Okay, so I'm going to have, the next odd integer is going to be whatever the first odd integer was, plus 2, okay? The third odd integer is going to have to be 2 more than that, right? 1 plus 2 is 3, 3 plus 2 is 5, etc., etc. So the third odd integer is going to be x plus 4. I'm going to have to add 2 more, okay? There's my equation. All right, so let's simplify a little bit. I have x plus x plus x, so that's going to be 3x. I have 2 plus 4, so that's going to be plus 6. So I end up with 3x plus 6 equals 189, okay? Well, let's solve for x. Minus 6 minus 6, I'm going to end up with 3x equals 183. Then I'm going to divide by 3 on both sides. That's going to give me x equals 183 divided by 3 is 61. Let me double check that for verification. Yeah, it's 61, okay? So you might be tempted to box that in and be like, there's my final answer, x is equal to 61. But note that this problem said, what is the middle integer? So 61, that's x, that's my first odd integer. My next odd integer would be 63. My next odd integer would be 65. And if you double check and add all 3 of those together, you'll notice I will get 189. Okay? But that means the middle integer is 63. So my final answer would be 63. So that problem had a few different parts, a few different steps. But there you go. That's how I go about solving that problem. Pretty fun one. Pretty common, or a pretty useful plan of attack there for similar problems on the ACT. Okay. Let's go ahead and do one off of the homework assignment if you're following along with me on a homework assignment. Number 11 on the homework assignment says, if a rectangle measures 54 meters by 72 meters, what is the length in meters of the diagonal of the rectangle? Okay, so I have a rectangle here. Oh my heavens. That's good enough. Okay, it measures 54 meters by 72 meters. What is the length in meters of the diagonal of the rectangle? Well, if you don't know, a diagonal of a rectangle is the line connecting 2 opposite corners. Let's see if I can make that a straight line. 2 opposite corners of that rectangle. Okay? So first glance, maybe you're like, I don't know what I'm supposed to be doing here. We haven't explicitly talked about how to solve this problem, but I've set up this story problem. Note that if I erase half of this rectangle, I'm left with a right triangle. Well, what do I know about right triangles and how to find the missing sides of a right triangle? Well, hopefully in the back of your memory, you know the Pythagorean theorem. A squared plus b squared equals c squared, where these 2 legs, formerly the sides of the rectangle, are a and b, and the hypotenuse is c. So in order to solve for the diagonal, that missing side, I'm going to go 54 squared plus 72 squared equals c squared. Okay? 54 squared plus 72 squared is going to give me 8100 equals c squared. And when I square root 8100, I'm going to get 90. The square root of 8100 is 90. So the correct answer here would be C. Ironically, that's what I labeled the side as. But the length of this hypotenuse, this diagonal of the rectangle, is 90. So that's another example of a story problem that we solved a slightly different way, but the kicker was being able to set up the problem, create an equation in order to help me solve the problem, and then actually solve. Okay? So that's it. Hopefully you feel a little bit more comfortable writing out these story type problems. Those are going to be super helpful on the ACT. Please let me know if you have any questions, and I hope you had as much fun as I did.